So now we're going to talk about complement. We talked a little bit about it earlier with regard to the complement proteins that are in your serum, and some people say it makes up about 7% of your serum proteins. So there's a couple of different pathways of how you can activate complement, and the pathways are called alternative pathway. Okay, and that's part of your innate immune system, and you don't need any kind of immunoglobulins in order to activate the alternative complement pathways. You have the classical pathway, and classical you need IgM or IgG. Okay, so this is a link in that you have some adaptive immunity with IgM and IgG, and then you also have this component that has some link back to the alternative pathways and a common pathway, which we'll talk about in a second. And then the last is called this mannose-binding lectin, which I'm not going to even write up because we won't go into it, and it's not a particularly so-called high-yield area with regard to complement. So let's go through the alternative pathway first. So here's the notion is essentially, well, let's back up for a second and talk about what complement can do for you. We already talked about opsonization ad nauseum yesterday with regard to C3b. So I kept referring to complement as being C3b, okay, which ends up, lo and behold, on a pathogen. And then you have a C3b receptor on your phagocytes, or a complement receptor, as we call it, complement receptor 1, on the phagocyte that then enables this to be opsonized. So that was one thing with regard to opsonization. And remember, it's particularly helpful with those slimy, candy-coated type glycopolysaccharide bugs that you have out there in order to be able to phagocytose them. So opsonization would be one component or one advantage of complement. And the other that we talked about yesterday as well were called anaphytoxins. Okay, and we talked about C5, we may not have labeled it that, but we talked about C5a in particular, okay, and we also have C4a and C3a. Now we're going to go through how you end up getting these little molecules in a minute, but I just want to say where we're going first and give you the roadmap in terms of the anaphytoxins. And what these do is mast cells and basophils as well have receptors for C5a, C4a, C3a. So your mast cell has a receptor, this binds here, and then the mast cell secretes one of the major active components is histamine, as well as some other vasoactive components, particularly with regard to inflammation, allergy, and so on, which we'll go into. But the one, as we mentioned before, is histamine is the main thing that gets secreted when C5 binds to here, to the receptor, and then that activates the mast cell or the basophil. So the other component that we haven't discussed as much is the third component of complement, which is quite interesting. It has its own cytotoxic component as well. We've talked about cytotoxic T cells, CD8 positive. We talked about NK cells are also cytotoxic, but there's also this component which we call the membrane attack complex. And those are complement proteins that if the complement gets activated, it will essentially drill holes and you'll get a osmolysis or lysis of the particular cell. Okay. Now this can happen on a pathogen, for example, Neisseria gonorrhea, Neisseria meningitis. It can also happen on your own cells, which is not too great, and so it can cause immunopathology, as we call it as well. So those are the three things: opsonization, anaphytoxins that will activate mast cells, and then the third thing is a cytotoxic function, which are the membrane attack complex. So let's talk about how complement works, and then we'll go through some quiz questions. So the first thing, we talked about alternate complement. Now this is kind of interesting because what happens with alternate complement is, let's say this is a cell. It could be any cell. It could be your cell. It could be a bad guy's cell. Let's say it's a bad guy's cell, okay? And what happens here is C3, okay? C3 is complement protein 3 will bind to this, and then there's this process called tick over. And don't ask me to explain it. I've never seen it explained in detail, but essentially C3 is automatically split, okay, and basically becomes C3b, all right? So when you think about complement, it's essentially one molecule is acting on another one to cause a bioactive substance. So bear with me and look at the way that I draw it out is I'll take, so realize that, you know, we're talking about complement here, okay? So I'll take 3B3 and then 5, 6, 7, 8, 9, okay? So the C3 gets split into C3b by this automatic tick over, all right? And then what happens is B, factor B, okay, comes in here. And I think of it like, sort of like sitting next to the bar stool. So let's say C3 is here. By automatic tick over, it goes to C3b. And then big B nestles into and sits next to little miss C3b at the bar stool, okay? And then we have what we call factor D, okay, factor D. D, you can think of it as drinks are served, okay? So D comes in and splits B, okay, into this. So you get C3B, BB, all right? And then this, so this is factor D and it becomes factor B. I'm going someplace with this, bear with me. And then what happens is we call this, these two together, C3b, BB, we call that the C3 convertase, okay? The C3 convertase for the alternate pathway. And what this does is that acts to split C3, and you get a C3b again, and you come over here and you get C3a. Now realize it's not just one C3b that happens. You get you know, times, you know, just several different C3Bs. Why is that important? It's important because now you have all this C3B in the system, okay, to bind to all kinds of little bad guys out there, okay? And now you can see how this is going to enhance your ability to clear these little guys out of the system, okay, through opsonization, right? So that's the beauty of that particular mechanism. Now, what happens here is there's one more component to this that I didn't discuss of the C3 convertase, and that is a stabilization molecule called properidin. Properidin. Okay, I'm not sure if I'm spelling that right, but you'll see it in the quiz. Properidin stabilizes this. Okay, so it stabilizes that and makes it more effective. Now, don't think I'm too crazy here, but okay, so now we have the C3 convertase. That's going to split that C3. Now we have C3b and we have C3a, which is an anaphytoxin, but we'll talk about that in a minute. Now then we have these guys, so now we're going to add C3b into the mix here. All right? C3b into the mix, and this whole thing becomes C3, or sorry, my apologies, C5 convertase, all right, C5 convertase. Okay, now this, all right, is going to split, right, and you get C5b, and now you get C5a, okay? Well, and C5a is a critical molecule that we'll discuss in just a moment. We've already introduced it slightly. And then that enables this whole cascade here, which is the membrane attack complex. And what's beautiful about this particular pathway is that this membrane attack complex is common to the alternative as well as the classical pathway. Okay, so if this happens, if you get a C5 convertase, you'll take it, you'll split the C5b, and then you can get the membrane attack complex. Once this thing goes all the way through the membrane attack complex through C6 to C9, at that point, you're going to have autolysis of the cell, whatever cell that is, whether it's self or non-self. Okay? So let's back up for a second. theoretically, okay, if this is your own cell, you're not going to get this cascade, hopefully, all right, because there's regulatory protein. But if it is a bad guy, then, you know, hopefully it will go through this whole process. So the important things to pull out of this, all right, are that, first of all, you have tick over, all right, and that's how you get the C3b to begin with. The B comes in and binds, sits next to the bar stool there, if you will, if you'll pardon my analogy. And then factor D, drinks come in and split the B to BB. These two together, C3 convertase. So the question might ask is, what is this C3 convertase for the alternative pathway? Or they might say, what activates C3b, or how do you get C3b? And it would be C3b, big B, big B. That's the C3 convertase. And I'll show you that in a quiz. Okay, then this splits just your straight up C3b, and you get several bioactive components, C3b, which we talked about for opsonization. And then these combine to your C5 convertase, which is nothing more than C3b, BB, and C3b again. That's your C5 convertase. And where that is so critical is that it gives you this anaflatoxin, the C5a. Okay? Let's erase all this and talk about those anaflatoxins, because C5a is not just an anaflatoxin. It's a very special molecule from the standpoint that it is a chemotactant. And chemotactant, the way it was described to me, actually by Dr. Burns at St. George's, was that it's sort of, chemotactants are kind of like breadcrumbs for the immune cells, okay? So it's essentially will attract neutrophils, okay? So that's what C5 does, is it not only causes the degranulation and histamine, if you will, or histamine release from a mast cell, or a basophil, but it will also attract neutrophils. And remember, neutrophils are the first guys on the scene of the crime, whatever it is, tissue damage. They clean up the mess. And so it's very instrumental in inflammation, which we'll go into as we continue. So that was the alternative pathway. Now let's talk about the classical pathway. So classical pathway, as we mentioned, you're looking at your immunoglobulins, IgM, IgG. Okay, so IgM, you only need one IgM molecule to activate the classical complement. Why? Well, because it's pentameric, okay? Meaning that, you know, we know penta means 5, okay? So you got basically these 5 guys, not very, drawing it very well. But what you need is, you need 2 adjacent FC receptors. Okay, and then what happens is, and we'll go into it, is you have your C1, essentially, unit binds in here. So you see how that only takes 1 molecule. That's why we talk about IgM being pentameric and only taking 1 IgM molecule to activate complement. And remember, it's interesting because IgM is your first immunoglobulin on the scene, okay, when you have an infection or you're producing immunoglobulin, it's your first one. Okay, just generally, just throw that out to you, but so you see how IgM works with regard to the FC receptors. IgG, on the other hand, you need like 600 or so molecules. They say 600 to 1,000 or something. So that's just something that occasionally is tested. 1 IgM, you know, hundreds of IgG to activate classical complement. So this has slightly different proteins than the other one, than alternative. So this is the way I do this: is 14, 23. 5, 6, 7, 8, 9. So you can see that this part is common to both, right? So you have this C1, and there's a Q, R, and an S, which isn't, you know, as per se important. I don't think I've ever seen a question, but Q is well, we won't go into that, but essentially, let's just stick with the big picture here, because, or the things that they tend to like to ask. So what happens is, as we said, you've got to have the IgM or IgG, And oh, by the way, with regard to IgG, there's several subtypes. There's 4 subtypes, and only 1, 2, and 3 will activate it. That's a question sometimes it's asked. So 4, IgG4, type 4, is not something that will activate complement. Throw that out there. I think we have a question about that in a minute. Okay, so here's what happens is you saw how that bound to the 2 FC, adjacent FC receptors. Got in the right configuration if it's an IgG. So this, okay, so you get the C1, and essentially you split this, okay, and it comes off here to C4A, and this is C4B, all right? And then you also get a split here into, this is kind of the oddball, 2B or not to be over here, and this is 2A, all right? And then these together, this becomes the C3 convertase, splits this, and again, it's the same story, different day, C3B, okay? And then, so this is the C3 convertase, all right? And again, it's the same story in terms of not just this one C3, but a whole bunch of C3Bs, all right? And then you get the same story with the opsonization, so similar. And then these guys together, that's your C5 convertase, C5A, C5B, okay? And then you have your membrane attack complex, which is common to both pathways. So that's your complement, all right? That's your classical complement. So if you get the question of what's the C3 convertase for complement, for classical complement, it's just C4B2A. And if you say what's the C5 convertase for classical complement, it's these guys. So we have 4B2A and 3B. So that is the bioactive mechanism for your complement. Now, question is regulation, okay? So we talked about some of the different regulatory mechanisms of complement. So first of all, we showed C1, right? Okay, so we have now we're talking about classical complement. So we have a C1 inhibitor protein, okay? So C1 inhibitor protein, sometimes you'll see it's called C1 esterase inhibitor. So the clinical correlate here is if you don't have this particular inhibitor protein, so that C1 starts activating everybody, then you have what they call angioedema or hereditary angioedema, because remember that this is very vasoactive, right? Because in this complement, you ended up with all these anaphytoxins. All right, and C5A we'll talk about a little bit more with regard to its other vasoactive components, because it also results in bradykinin, which also has some vasodilatory properties. So if you see a picture of somebody with big swollen lips, for example, on an exam, and they ask you what complement component may be deficient or pathological, you'd be a C1 esterase deficiency, C1 esterase inhibitor deficiency, all right? So then you also have what they call a factor I, which is just inhibitor. Factor I for inhibitor, pretty easy one there, and that essentially will cleave the C4B, and we'll get to these, actually probably better use of time to go through these in terms of the quiz questions. The last thing I'll say is, just because it's sort of the one that gets forgotten a lot, is there is an anaphytoxin inhibitor, but I've never seen it asked. But those anaphytoxins, remember C3A, 4A, 5A, there is an inhibitor for those. So let's go through one other point that bears discussion is there's what they call a decay accelerating factor, okay? And when we go into immunopathology, we'll unpack this more, but decay accelerating factor is going to essentially prevent the autolysis. So if you have, for example, factor I that's soluble, or you have factor C4 binding protein which competes with the C4 so that you don't get that action of classical, But you also have a membrane-bound protectant called decay accelerating factor. And so that's going to prevent autolysis, that membrane attack complex, and the autolysis on your own cells. Okay, so just one other thing on this with regard to alternative pathway. You still have factor I, okay? And you have what they call factor H. So remember we had this C3 and it went to C3b by tick over, and then B comes in and binds next to it, all right? So we have a factor H, all right, which I say, hey. So it's as though someone in the bar says, hey, wait a minute. You can't come in here, okay? And so it essentially stops that process. So factor H is specific to the alternative pathway, and that's where it acts, one of the places it acts anyway. And then the other thing is that it also has a decay accelerating factor, just like, it's a common pathway for membrane attacks, it's a common regulatory protein. So let's quickly go through the review questions on complement, make sure we're comprehending this. So question number 1 is, name the complement fragments that are called anaphytoxins. And that answer is C, C3A, 4A, and 5A. And we'll talk about those other answers when we get to cytokines. Question 2 is, which of the fragments in question 1 is chemotactic for neutrophils? Remember, these are the breadcrumbs for neutrophils, and that's going to be answer B, which is C5A. Number 3 is, what cells do the anaphytoxins activate, which results in degranulation? So we talked about that. That's answer D, the mast cells. You could add basophils to that if you wanted to as well, but that's not one of the answer choices. Number 4 is, which complement cascade is antibody dependent? So that, again, is classical. Which ones? IgM, IgG. Which is more effective? IgM. One IgM activates complement, whereas hundreds of IgG activate complement. In terms of, or classical complement. In terms of number 5, what are the components of the alternative pathway C3 convertase? Remember that C3 convertase is very powerful, splits C3, gets all the C3Bs, and that answer is going to be B. So that's C3B, BB. All right, if you look at A, that answer, C3b, BB, C3b, sounds ridiculous. That's C5 convertase, all right, for the alternative pathway. If you look at answer C, that answer, C4b2A, that is going to be your C3 convertase for classical pathway. And then if you look at D, C4b2A, 3B, that's going to be your C5 convertase for classical pathway. Number 6 is, which of the following complement receptors is found on erythrocytes and enables immune complex elimination? Now remember that we talked about with regard to complement receptors, okay? So let's go through this quickly. We have complement receptor 1, okay? And that, remember, was the C3b. And the guys that have that are going to be your neutrophils, your phagocytes, okay? Just in general, but also red blood cells. Okay, so why do they have it? Well, you get this complement activation, as you might imagine. You have these immune complexes where you have immunoglobulin with complement together on a bad guy, and then you want to haul this trash off to the spleen effectively, and so the red blood cells are the guys to do that job. As you know, they all go through the spleen, and they can be eliminated through the spleen in that way. Okay, it's worth mentioning at this point in time that there's also a complement receptor that we talked about, that we didn't talk about, complement receptor 2. Okay, actually I'm going to come to it. My apologies. So that is. Let's look at 6 again, though. The other answers: A, C-reactive binding protein or binding site. that's going to be, again, opsonization, and C is opsonization, but answer B is CR1, which is erythrocytes. And remember that CR1 is also on the phagocytes for opsonization, which is what we just talked about. Number 7, B cells have the following complement receptor that is also targeted by Epstein-Barr virus. The ligand for this receptor is C3bi. Okay, and that is complement receptor 2. So the B cells have complement receptor 2. And remember that EBV infects B cells. That's who she's interested in, okay? And so this is also targeted by Epstein-Barr virus, this particular receptor. Okay, and C3bi is a component, is one of the components of complement, but suffice it to say that that's its ligand is C3bi. Number 8 is what stabilizes the alternative complement pathway? That's piperidin. Remember, when you got that C3b, BB, the C3 convertase that's bound to this cell, okay, or essentially, parks in there, that's stabilized by piperidin, and that answer is answer number C. Number 9 is, how is complement started in the alternative pathway? The answer is B, tick over. And remember, the A would be for the classical pathway. A also has IgA included in there, and some texts will refer to IgA having some effect on complement, but it's not something that I have seen in exams or in review books. But again, it's probably, again, I know this much immunology. If you look at the big picture of things, the main focus is the IgM and the IgG. Number 10 is a deficiency in C1 inhibitor, okay, will result in what? And the answer there we talked about was A, angioedema, and D, we haven't discussed in much, but when we get to inflammation, let's talk about that. Excess bradykinin due to activation of kallikrein, which probably sounds foreign to you right now, but it won't in about an hour or so. Number 11 is, which of the following prevents the complement cascade being perpetrated on self cells in the alternative pathway? And that is that factor H. Remember, this guy, B comes and nestles up next to C3b, and then, factor H comes in here and says, hey, that's my girlfriend, or however you want to look at it, okay? So that's actually going to be factor H is going to prevent that. And number 12 is, which of the following is our regulatory component of both the alternative and classical, which we went over, which is going to be A, your decay accelerating factor, and I, factor I, which is the answer of C. So the correct answer is E, A, and C above. And remember that the answer B, factor H, is part of alternative, and the answer D, C4 binding protein, is part of classical. And finally, number 13 is, which of the following regulates the terminal pathway? So the terminal pathway being the membrane attack complex. E, all of the above, is they are different names for the same thing. That's a favorite in immunology. They like to name the same thing a lot of different names, just maybe to confuse us, but essentially all those are the exact same mechanism. Thank you.